So hi everyone, I'm Holly and I was supervised by Brian Broderick and Breffney during my PhD. So my PhD was undertaken with the IRC employment-based programme with Bart Mahoney Consulting Engineers as well as Trinity, obviously, and it focused on the wind-induced vibration response of modular high-rise buildings. So first I'll give a bit of background about what modular construction is and some of the habitability requirements that are necessary for high-rise buildings. I'll speak more specifically about 10 degrees Croydon, which was the industry-based part of the research, and the wider impact this research has had, as well as some conclusions. So modular construction fits into these guidelines set out by the Ministry of Housing in the UK. The type of modular construction we focus on fits into category 1, so 3D structural systems. So it's basically room-sized units constructed off-site in a factory-like assembly line, and they can be transported to site and stacked around something like these concrete cores on the right there to make a finished building. So in the last 30 or so years, it's been a lot more, has seen a lot more interest, but it has typically been used in stuff like military accommodation or hospitals where it's repetitive units. So this is kind of the first time it's been used in high rise in the last 30 or so years, mainly due to its many benefits. So it's really rapid. It's reported to have a lower environmental impact. It can be quite high quality because it's all made in factory and more economical with less on-site labour as well. So as this form of construction pushes to new heights, it also encounters new problems. And as for all tall buildings, as they become taller and more slender and flexible, the wind-induced vibration response can become the governing design criteria. So one of the main problems with modular construction is that we don't have, before this research, there was no prior in situ monitoring of this type of building. So we'd no idea we'd no informed idea, I suppose, of what the inherent properties would be. So in particular, what its damping ratio would be, so how quickly it can dissipate vibrations, and what its natural frequency would be relating to how stiff it is. So this obviously brought about issues when we went to investigate whether it was suitable and met SLS design or habitability requirements. So habitability requirements are normally set out based on lateral accelerations, and if they're exceeded, it can cause issues like occupant discomfort or nausea and difficulty concentrating. So obviously if you're paying millions of euro to build a building, you don't want issues with your occupants feeling sick. So we need to make sure that modular buildings, as they reach these new heights, can meet these criteria. So that's how we began our industry partnership. So 10 degrees Croydon is a building in Croydon, London. And it was, at the time of completion, the tallest modular building in the world. Since a building has been built right next door, which is a little bit taller, which we also studied. So as you can see there, the construction was really rapid, just under 2 years, and it produced 546 apartments. And our partnership began with Bar Mahoney when they were designing this, and they weren't sure if initial models kind of gave indication that maybe SLS requirements would be exceeded, and they needed to make sure that they weren't going to be. So they did wind tunnel tests, which is the typical kind of initial starter point, but we didn't know the inherent properties, we didn't know the damping ratio, and we didn't know how stiff it was, so the wind tunnel tests couldn't be that accurate without knowing those properties. And with the uncertainty about these modal properties, we just didn't know, basically, if serviceability issues would be a big problem. And that's where we began in situ monitoring. So we put accelerometers at the top of the taller core, and we had them there for about 6 months. So 10 measurements were taken during construction as well, which actually later gave us really interesting insights into how stiff the buildings were. We recorded accelerations for 12-hour periods during significant wind events. And we were able to then, from those, apply modal identification techniques, so something like a Fourier transform to get the natural frequencies, and then more advanced techniques to identify the damping ratio. So interestingly, we found that the damping ratios were actually really close to values recommended by Eurocodes for mixed steel and concrete buildings. So we found the damping ratio to be about 1.1%, and the recommended value is 1.27%. So our initial guess maybe wasn't so far off. So that's had a wider impact then and enabled improved design of modular buildings. So if you look at the figure on the right, we have 10 degrees, which is the green building, and then College Road, which is the white buildings. So they're currently the 2 tallest modular buildings. We say in Europe because there's ones made entirely of concrete in China, but there's dispute over what category they fall into. But anyway, so the 2 tallest modular buildings in Europe. And through this research, we've been able to inform design and give more confidence that SLS requirements are met as they go forward. And there's planning for further taller modular buildings then in London again. And actually our research for this won the iShakti 2024 Research into Practice Award as well, which was a great achievement. So from all this and this kind of one set of data, we were able to do a lot of research, a whole PhD work, and continuing research, I suppose. And that helped us identify the damping ratio, the bending stiffness, and the mass of this form of building. And from that, we were able to build multi-degree of freedom surrogate models, which then can be used by Barratt Mahoney or our industry partners to better design these buildings and have more confidence as well. So yeah, basically there's high-rise modular construction presents a lot of opportunities and challenges, and through our research and getting in situ data, we enabled improved assessment of serviceability issues, and this facilitated further research questions and development of useful tools for the design of modular buildings, and it's had a direct impact which enables more confident design of modular high-rise buildings. And then we just have some of our industry partners there. So I suppose the main one was Barratt Mahoney Consulting Engineers, but the buildings are funded and designed by Tide and Vision, and MJH designed the modules, and BMT did the wind tunnel testing as well. And then just some further research. I don't know if the slides are going to be shared after or not. Thank you.